Wow. I got to thinking, when I describe how I take a bow and I use my Scribe-O-Matic, oh man, everything, oh there it is, Scribe-O-Matic to mark reference lines for the thickness, so it's tapered, it can be kind of confusing. So this is take 3, and hopefully, because I listen to them and I figure out where did I screw up, so it's not ambiguous. How can I describe to you what I mean by going beyond this line and that line and breaking into thirds and thus far and fore out and whatnot, etc. Okay, this is the center of the handle, right here. It's an even, very close to 29 inches from the tip, center, 29 inches, then to the other tip. You need to know the center of the handle. Then I break the bow into close to thirds. In this case, let's make sure it's right side up. Got 9 3/4 inches from the tip to the first third. Then 9 3/4 inches to the next, and then actually 9 1/2 to the handle, which is close enough for government work, as they say. So basically, I broke the bow into thirds. Okay, that's pretty easy. Where it gets tricky is when I describe how to use this thing. I'm going to start at the center. You can start at the tips, whatever. But I'm going to start at the center, and I'm going to adjust this so this rides along the edge of the back, and I can scribe a nice line. Now, if you wind up getting pencils, especially, pens are good. You know, put a skinny pen in there. I'll get a nice, even thickness, unbroken line that's not wobbly. It's important. If you're ever marking your bow for thickness, even though it's a rough thickness, and you get a wobbly line, or else you have to go back over it, and then suddenly it's different because you rock this, so you've got 2 lines there where there should be just one, sand it off and start over again. You got to work precise. You need to have every line that you draw on here precise, nice constant width, just beautiful and crisp. And if, or however you want to say it, you don't feel that those lines just aren't right, or else when I was scribing this side and I went to scribe the opposite side, the last thirds, I bumped this, or the pencil got shoved in and it changed the thickness. Do it again. You need to be precise in this. Now, where it gets tricky is, okay, center of the handle. I'll just keep my finger here, center of the handle. When I talk about I'm going past a reference line, well, what the heck does that mean? So I drew this diagram because I care. This is the center of the handle. This is the tip. This dash line, and then the next one up, and then the next one up. These are the lines that I drew with this thing. And when I say I go past the third mark, that means that this line, this is the handle section, the thickest part, is that when I'm scribing this line, this is the back, this is the belly, I'm going beyond that third mark. You could go all the way at the end if you want, but you have to go beyond that third mark. And then I pinch it, and I'm doing each quadrant at the same time. I've got this. I scribe that first, the thickest. This is the thickest. This is near the handle. Then I go to the other side of the bow. Did this. And then I flip it over. This is the same. And I do this side. So I do all the quadrants at the same time. Well, not at the same time. Need to be precise here without moving this thing, the thickness. So I'll do the thick handle portion. Then I'll pinch it in a little bit so it's thinner. I mean, thinner from the back of the bow. Then I start, this is the first third, this is the handle, this is the tip. I start before that line, zoom, and I pass the one that's towards the tip. The lines are actually going to be doubled in this area right here. So I pinch this, do the other tip, flip the bow over, do the other. There's 4 quadrants really. This is the tip. This is the thinnest part of the bow. I pass that third mark. That's what I mean by passing the third mark. So whenever I have the bow thirds reference line, in the vicinity of that line, I've got 2 thickness lines. Questions? Ask away. Too bad, you know, if I was streaming I could do that, but I don't stream. It's too technological. Okay. Now, when I'm talking about, I put my bow in, I use my farrier's rasp for this step. You think about that for a bit while I do some stuff. I want the jaws to be parallel because it's less likely to have any slippage if the jaws are parallel. That's parallel enough. I use my farrier's rasp. Now keep in mind, I am looking at a line that goes the length of the bow right here, that thickness reference line. This is my first third mark. I'm seeing a line there, right there. If I have to erase this whole thing with sandpaper, I still have it marked on the belly, so then I can just put it back on the side again. I see a single line, and I'm looking ahead at my line that indicates the third, and then it passes that. I see 2 lines there. I don't want to have it a constant thickness and then a step, that constant thickness through the center of the limb, and then a step, and then the handle section. I want it to be a constant taper. That's why I have this first line referencing the thickness, passing that third mark. Now when I say I am going to eliminate, back up, this is the tip. This is the third, this is the third, this is the center of the handle. I break each one of these third quadrants into thirds. So tip, mark indicating the outer third of this limb, it's broken into 1, 2, 3 quadrants. As I'm going towards the center of the handle, I use this. This is how I do it. You could probably use a draw knife if you wanted on a clean piece, but I don't want to have any tear out. I use this, and I angle it away from the bottom side, so I'm not going to go inside my line on the side I can't see. And so I do it at an angle. As I grind, and when I do this, I usually pull it towards me, not into the fibers, because it's tapering, it's getting thicker this way, it's getting thinner this way. So I tend to, pull it towards me. So I'm going away from new fibers, instead of going into them, risking tear out. But when I say I eliminate the pencil line, my reference line or pen line, in the first third of each quadrant, because again, see, I've got one, then I've got it thicker, and then I've got it thicker yet. When I break it into thirds, and I eliminate the line through the first third, and then ride so I could see that line in the second, 1, 2, 3. When I eliminate the line here, just as little elimination as possible. I just want to get rid of that line. And then I'm on the line, and then I'm slightly above the line this way. It means I'm getting thicker and thicker and thicker and thicker and thicker. I'm doing that actually pretty precisely. Okay, I just eliminated the line, let's say in the first third, and now I'm grading it, not creating steps, but using my ice and my mind and my hands and my farrier's rasp. to not see that line in the first third anymore. Now I am on top of the line, and now I've got some wood on the belly side. It's thicker on this line, and now I've just hit a thicker reference line. So I've graded it, I've created a taper, and now I'm in the second third. This is the middle third of that limb. I eliminate the line, this line, not this one, but this line. Now I'm riding on top of that line that continues on. Now I've got a little bit of wood above this reference line. Now I've entered the thickest one, the center section. Rinse and repeat. Break it into thirds, eliminate the line. Now I'm on the line, now I'm above the line. And when you do that, you have created basically a finished taper. You clean that up with whatever. I'm not going to use this to clean it up. Let's get the actual orientation. And I'm doing this. Because if I flatten that with this, because I've created a ridge, there is a ridge running along the center of this, because when I rasped it, I angled up, exaggeration, and when I did this side, I angled it up, exaggeration, so you can see, this would be flat. I work it this way to create a ridge down the center. Because if I flatten it with this, and I'm hitting this outside edge, I've just torn it out. And so the safest way is to not try to get, when I'm working the line on the left side, I'm not trying to hit it with the right side. That's why I've got the ridge. Now, what I can do is you can scrape it up, which is a very good way with a knife or a draw knife, you know, holding your draw knife like this to flatten it out. Look at it. I'm getting shavings and I'm not actually trying to push down. Or you can use an orbital disc sander. Now, once you hit that portion of removing that hump down the center, now, because you were precise in drawing, can't even pick it up, I need fingernails. These reference lines for thickness, and you were precise and you did it evenly along both sides, I'm starting to see growth ring stuff happening here. The thirds. See the thirds. The outer third, the tip third, the center of the limb, the handle third. Got it? I won't see a step in the growth rings, probably. You know, it's just average. A lot of times I won't see a step in the growth rings in this outer portion. Then I will see a growth ring. These point downhill. You know, the mouths point uphill, which means you're going up. You got a taper. But I'll get, say, an unbroken growth ring. This, oh yeah, middle fingers. This distance. And then the next one will be a little shorter. Then the next one will be even closer together. And then near the handle, the growth rings usually pile up a little bit. And that will give you an elliptical tiller. I prefer elliptical tillers over circular tillers. And what that means for the people that watch my videos for motorcycles or whatever, and you are now watching a bow video, what tiller means is getting the bend in the bow. A circular tiller means you're looking at a section of circle. You've got an even bend throughout the length of that entire bow. An elliptical tiller is an ellipse. A little less bend in the center, and as you go out, ever increasing bend. And there's a couple reasons why I prefer elliptical tiller over circular tiller. One is, I believe it makes for a faster bow. The reasons for that could be complicated and add another 20 minutes to this video if I was thorough and actually explained myself, which is hard for me. I believe the elliptical tiller bow will be faster than the circular tiller bow. I also believe that you're going to suffer less string follow with an elliptical tiller bow than a circular tiller bow. And the reasons being, okay, you can see the bow here. Right there. And this is, let's put it right at the center. There's my center. My Jorgie is right at this. Oh, come on, you. Look at this. parallel jaws. Okay, we're good here. If I was to get a permanent bend in the bow from the belly, which is the side facing you for your motorcycle people, you've got the back, which is on the other side of you, and you've got the belly facing you. Bows typically, and there's exceptions to everything, bows typically break because, bam, they can't handle the tension. They break because of the back. They get a permanent deformation. You don't want to have a bow that has a permanent bend in it after you unstring it. It's usually because of the belly. Compression. Wood will compress a little bit. This is Osage orange, so it's very resistant to that. And so if you have a circular tillered bow and you unstring it, you've got string follow. Generally speaking, you've got string follow in that bow. That bow's got a permanent bend throughout. If you have an elliptical tillered bow, you stand a very good chance of the bend mimicking the tillering of the bow, the ellipse. So most of the permanent bend will be out here. Okay, let's talk geometry. If you get all of your permanent bend in the center, this is what they would call a physics bow. If you've ever had physics class, this is the physics bow. If all your permanent bend is in the center, when you unstring it, then you take a string and you put it on this tip and this tip, that tip over there, and you just kind of tighten it. You're not putting bend in the bow, you're just tightening it so it's straight. You're going to have a pretty good distance between the handle and the string. Not good. If you have an elliptical tillered bow, you do the same thing. You unstring it, and then you just take a string and taut, vertically. You're going to have less of a distance between the handle and the string. The more permanent distance you have between that string at the center of the handle and the belly of the bow, the worse it is. And that's another reason why I like elliptical tiller. There's another kind, you see it sometimes, it's called whippy tiller. That means that not a whole lot of bend throughout the length of the limbs, but a lot of bend at the tips. And so it kind of looks like a straight thing with a bunch of bend at the tips. I don't want to get into a big disagreement. Some people like whippy tiller. I don't. I like to take this limb and devise a way to get as much bend throughout the length of it as possible, distributing the bend, but taking that bend and manipulating it so it's an elliptical tiller. That's just me. What else? And then there's hingy. That means you got a bow and the tillering is really bad. It only bends in one little area. And you can picture that's not good because you got this entire 59-inch long bow and all the bend is taking place in a total of 5 inches of that length. That, not so good. Distribute it. Spread the wealth. Well, I think I actually have explained to myself from what I mean by breaking these into thirds, breaking the thirds into thirds, drawing the reference lines that pass those third marks. So you've got 2 lines. This is the third mark, 2 lines here. And then in the first third, eliminating the line, writing the line, going above the line, and then repeating in each third. That's it. I think I done did it.